Hello, I am Josh Taylor, the Director of Product Management with Cable Express, and I'm here with Rick Dahlman, Senior Data Center Architect, also with Cable Express. Rick, how you doing?
I'm well. How you doing, Josh?
Doing great. So, wanted to talk to you today. I'm just back from a trip to a trade show, and one thing, well, there's always a lot going on in technology, a ton. IT is a very busy industry, but it seems like recently and preparing for the future, there is going to be a lot of disruption with transceivers. You really have a lot of expertise. You've seen a lot. What are you seeing now and coming down the pipe for transceiver change? Because I was seeing a lot at the trade show. Curious to learn more.
Well, that's a great question, Josh. You and I obviously go back a long ways. You know kind of my feelings about this, especially not only on the transceivers, but how, in fact, we're going to connect these transceivers into our high-end connectivity in our data centers. That, I think, is going to be the biggest challenge. I'm going to pull a presentation up right now that I did a few months back, titled Migration Challenges for High-Speed Applications, exactly what we're talking about. And it kind of addresses, I think, all your points, and it talks about the Cable Express solution, how we're going to address it, something that's been pretty passionate, a goal of mine for the past several years. We'll talk a little bit about, obviously, the driving factors of it. I actually been on several committees on the TIA board, so we'll kind of discuss what's going on in the committees and the arguments that ensue because of these particular challenges. We'll review, in fact, those transceivers with standards and also some non-standards, but also being talked about possibly could be standard soon. We'll review some of the cabling standards. And then obviously we'll put our take on what the challenges are, and then finally what our solution that we came up with, multipath, to address these shortcomings, in my opinion, for data center infrastructure that we deal with on an everyday basis, and especially moving forward.
Fantastic.
Of course, the driving factors, JT. Obviously, we're all familiar with LC and MPO style interconnects. So I'm not going to bore you with giving you fiber 101. But that in itself, associated with the transceivers that they plug into, are what really is creating some challenges because there's some different transmission methods that are required for these particular connectors. We'll talk about, obviously, the big buzzword lately in the industry has been OM5, the latest standard for shortwave multimode. We'll talk about that a little bit and the effects on the data center infrastructure. And we'll, again, just flat out talk about everything from 10 gig to 400 gigabit. And then, again, reiterating, and I can't reiterate this enough, the challenges for polarity or fiber path in the data centers. Like I said, this has been a big sticking point and challenge, I think, for the industry in itself. The buzzwords that everybody is familiar with structured cabling is plug-and-play systems, and to be frank, it's not plug-and-play. It's plug-and-play in the fact on how the actual material works together or the components work together. But the customer can't simply just buy a cable from any place and a cassette module from any place and plug it in and expect it to work. These are the challenges that we deal with on an everyday basis. All right? And then to throw some more fuel on the fire, some manufacturers out there have some proprietary methods with fiber path that are not in the standards that also prevent us from even complying to the standards across the board.
Okay, so, we've obviously talked through this. I've worked with you closely on these projects, but, in the past, we've seen some of these proprietary systems, and I don't know, what's a good example? Would you say MTRJ is a good example in a way of, it was a connector, standards-based connector, but yet there's a proprietary aspect to it. This connector, you're required to have all new materials, right? This is going to save your life. This is going to make things easier. It seems like constantly new things are coming out. Hey, this is going to be the greatest thing. But, we've been static, well, not static, but the LC has been predominant for a while now. You yourself, well, we've been working together 10 years plus.
Right.
You've been pushing the MPO or MTP connector for a long time. And you know, as time has gone by, I've seen how, I guess, wise of a push that has been. Is there, you know, I just want to point that out, but do you see, is that still a problem that these proprietary systems are being put in place? It seems like it's a waste of money a lot of times, and historically it has been a waste of money for many organizations.
Well, sure, but here's the good news. The good news is that as far as connectivity goes, there's really no proprietary, well, there is no proprietary connectivity that is predominant in the data center today, and I think looking towards the future will ever be. The industry is pretty much settled on LC, okay?
Yep.
Back in the day when connectors got smaller and then the small form factors came out, there was a big competition in the marketplace to see which footprint was going to take effect.
Okay.
And LC won out predominantly because of its performance characteristics and things of this sort. The other interconnect is NPO. Some people refer to it as different names. Some people call it NPO. That's actually the industry standard name for it. There's some brand name out there. Most people are familiar with it by MTP. Relatively recent and new technology to some people, but it's actually been around for quite some time. Back in the day when you used to be able to pre-order mainframe systems that came pre-cabled directly from the manufacturer, they were cabled up with these systems. For years, and again, it's been 20 plus years really for this particular connector. But it took off in the marketplace, a few years back when the standards for 40 gigabit were developed around this particular connector as an active component rather than just a passive component in the market. But again, what we talked about earlier, this is what inherently brings in challenges in the data center because the MPO has a polarity associated with it because it's a multi-fiber connector. It also has a gender associated with it. Okay. Because every time that you plug an MPO together, whether it's a cassette module, a feed-through adapter, or actually into a transceiver, one side has to be male, one side has to be female. The male side has alignment pins. That is necessary because there's 12 fibers in a very small package, and alignment is critical for fiber optic performing connectivity, so to speak. Yep. And then also when we start talking about, and we'll get into it now if you want, we'll talk about obviously the higher speeds. Utilize this connector to transmit multiple lanes, for lack of a better term, of gigabit or data down the pipe. And it does not transmit as a fiber 1-2, which we're kind of associated with the duplex LC model, but it transmits over parallel optics, which utilizes the first 4 fibers for transmit and the second for the last 8 fiber or last 4 fibers, 8 to 12, for receive. Okay. So inherently, that's how the challenges come into effect. All right. But yeah, and then if that wasn't challenging enough, we're already talking about 200 and 400 gigabit. In the marketplace. That's going to use an MPO-based style connector as well, but possibly, increasing the ferrule size up to 8 and 32 or 16 and 32 fiber positions. And then obviously with the relatively new release of short range single mode in the data center, it's becoming actually very cost effective to actually run single mode in your data center. But again, transmitting on parallel optics using the MPO. And again, we talk about proprietary systems as far as paths go, and it prevents you from following some standards in the data center if, in fact, you choose to go single mode with this particular connector. All right, so let's jump right in. Let's talk about what's standard and what's not standard. Okay. So, and this refers to the IEEE standards for high-speed Ethernet, obviously, which proposes the challenges. So, obviously, we all know that there's a whole laundry list of challenges with performance characteristics, with link distance and loss budget and distances. We're not going to talk about that today. Okay. We're going to talk about simply fiber path. So again, these standards have been around for a while. The 802.3 B standard and again There was a BA, BM, BS. I won't bore you with the acronyms and things of this sort, but it started about 8 years ago. It's been updated a couple times since, but long story short, it's a standard for 40 and 100 gigabit, and also talking about 200 and 400 gigabit transmitted on an MPO style interconnect. The individual fibers or lanes will transmit anywhere from 10 gigabit to 25 gigabits per channel, all the way up to and including going up to the next range of 50 gigabit, and then finally 100 gigabit per channel, multiple lanes of traffic. Okay, we have on the single mode side, so kind of the same principle, but then going over to the duplex LC, single mode can transmit those high speeds on just a duplex style connectivity as well. Right. Also in the marketplace, those of you that are familiar with Cisco or have used Cisco, they have a BiDi technology which transmits 40 gigabit on a duplex style LC interconnect. That was proprietary technology. They have released it to the marketplace, and now it's available to everybody. However, it's not a standard. There was talk that it was going to also offer 100 gig BiDi, but rumor has it that that's not going to happen. Right? But you also have the existence now. Obviously, we mentioned OM5 earlier with shortwave division multiplexing. That's going to take advantage of some higher window wavelengths on multi-mode cable, similar to some of the single mode technology that we're familiar with. And it's going to basically transmit multiple wavelengths of signal over a single fiber. Okay. All right. However, the challenge there is that obviously there's no electronics on the marketplace. We don't know when they're coming. The highway, so to speak, has been spec'd, okay, but the electronics side of the marketplace is not there yet. And who knows when those electronics come out, a year from now, 6 months from now, 2 years from now, there might be different technology again in the marketplace. So these are all, again, critical things that we have to, take advantage of. But the long and the short of it is, okay, and this is, I guess, why we're having this conversation today, is that for our perspective in the industry, and we see it today, there's going to be a mix of technologies that are going to be run in the data center. We see it on an everyday basis now. Obviously, 3-layer type design for structured cabling is still there. However, spine and leaf has really taken off. And they use 100 gig uplinks. They need to split the signals out, for say 425 gigs or 410. 410s. That's one good thing about the technology, and that inherently is where the challenge is at stake. Because again, you can transmit high speed on duplex LC. You may require parallel optics using the MPO. So your infrastructure has to be flexible and easy to migrate cost effectively. And if you're trying to follow the standards, which is always a good idea, quite frankly, there's no cost-effective, easy way to do it. You basically choose one method, and you're going to have trouble converting when you switch transmission methods. Simple as that. And that's inherently what Cable Express has been working on for some time now, and we come up with a solution on how to address that.
But Rick, this is great. So I just want to make sure I'm following you, and because this is exactly how I came out of the show, and this is a lot from talking to IT professionals, not necessarily the presenting programs, but there is a lot of uncertainty on. But there's certainty that the speeds are going to get faster. That's clear historically. So we know that. There's uncertainty in how it's going to be done.
Correct.
And we've seen this, for example, the 24 fiber MPO fair. Right. You had to have it. Well, no, you didn't. Add into that some proprietary technology, namely Cisco bidirectional transceiver. Hey, it's a great, it's a great piece of technology, but potentially a Band-Aid, but also outside of the standards, which is very important, or certainly a factor. Now added that into the market we know and we love, that now there's multiple different ways you could do this. Cost is huge, and listen, you and I know better than anybody, as well as all of our customers. Adding cost and infrastructure every generation of hardware upgrade is a nuisance, to say the least. So, I guess really that goes right into, what I'm looking for you to present is, what's the solution in this environment of uncertainty, of, disruption. We know things are going to go in a certain way, but nobody really knows how we're going to get there.
Right.
Nobody's got a crystal ball. Right. So how the heck do you do this?
Well, so here's the thing. So again, we talked about the different style of transceivers. Actually, I have it. If you guys want to take a look at the screen right now, I have obviously the transceivers that are on there. Obviously, you see, the MPO-based optics. You see the BiDi-based optics, along with what would maybe look like duplex LC as far as BiDi goes, and/or wave division multiplexing goes. There's obviously a push for 25 gig and 50 gig over a duplex style signal. That's where it's headed. But case in point, and you got to think about it, right? So you have an existing data center, okay? Because everybody's not building that new,
right?
Okay? So you have multiple millions of dollars invested in your infrastructure, utilizing a certain style of transmission technology right now. Say you're using BiDi, for example.
Yep.
And then now, you bought the latest, top of row switches, and you're got the latest core switch, and all of a sudden, boom, 100 gig uplinks that are using SR4 or QSFP MPO-based optics. How do you connect that now? Okay. Well, sure. I'll order an MPO cable. I'll plug it in, but now I got to go out to say my top of rows that have LC-based style interconnects. Well. Now all of a sudden, I'm switching over from a parallel optic system over to a duplex system and back and forth. Simply ordering a standard cable that we're accustomed to is not going to work anymore. Say, for example, again, it's all duplex-based interconnect, and now, I'm expanding out. I'm bringing in new pods, which is the big trend out there right now, building data centers out with pods. And I need to connect this into my system, and this is all, again, 40 and 100 gigabit base MPO optics. And I need to connect it into my existing infrastructure. And I have even if I have an MPO-based infrastructure with cassette modules, you would think that I'd be able just to, for example, pull those cassette modules out and put MPO features in and connect that moving forward. And that's simply not the case. And number one, it depends on the method that you're using. Number two, we have to worry about the genders. And then number three, I can't order the same MPO cable to plug in from, say, a machine-to-machine or in structured cabling because I have to be concerned with the genders in the path. It becomes very difficult to do, very, very difficult to do. And then again, the benefit to some of the LC-based higher speeds, whether we're talking about 25 or 50 gig, or if we're talking about what's going to be new. Over shortwave division multiplexing is that, the advantage of trying to stick with our LC-based infrastructure is that, obviously we can run it on a duplex path or our duplex system. If we think about it, if we use MPO, we have to add lanes or fiber, for example, to our system.
Yep.
Hence, more costs.
Yep.
Okay. But again, as you, I think, eloquently put, your infrastructure needs to be flexible because, it's in our opinion, and the majority of the industry's opinion, that you're not going to be able just to settle on one technology. You're going to have a mix of both duplex and parallel, and your infrastructure has to be flexible enough to go back and forth from parallel to duplex signal, and you need to be able to do that cost effectively. And besides Cable Express and the multipath system that we'll go over in a bit, there's simply no way to do that on the marketplace right now without spending big dollars. All right, so what are we talking about, JT? So here's what it boils down to. So the TIA 568.3-D actually was just updated. And what that does for us, and again, I'm a big standards guy. Standards are put into place to kind of keep us on the right path. Okay. But sometimes the standards can be challenging. You have to understand that number one, it has to be take care of the entire industry. Okay, so everybody can, for example, participate in the marketplace. All right, but I guess the inadvertent effect of the standards, unfortunately, is sometimes obviously creates confusion. And I brought this up earlier. The big buzz term for years, especially with MPO connectivity and MPO systems, has been plug and play. Okay.
Yep.
Hey, I need a trunk cable, I need a jumper cable, I need cassette modules. Boom, I'm going to plug this in. Boom. 2 seconds, I can terminate 12 fiber. Everybody is a fiber expert. Okay. I don't need to pay major labor dollars to have installers come in and terminate this. Number one, they can't get the performance that's required in our networks today. But number two, I can save a heck of a lot of money. Now, myself or my staff can do this and, be called, fiber experts, right? That's the beauty of it, okay? But again, here inherently is what the challenge is. Right now, in these particular standards, there's three methods referred to as method A, method B, and method C, all right? Each of which have, I think, advantages. Well, I shouldn't say that. Personally, method A. If anybody listening to this podcast hears the term method A, run. You want to stay away from method A. Why do you say that? Because method A kind of goes back to, I think, the old school way of bringing cable into data centers. They basically run a straight path all the way through from end to end, and then they flip it at one particular area. Then the next person comes in, not really sure where the actual signal needs to be, and they start flipping stuff, and you really never have a good system. It's very, I guess, highly labor intensive that you have to keep track of. Besides the fact, you can't just buy a jumper. Whoever you're might be buying it from. You call up vendor A and say, hey, I need an LC cable. They send you an LC cable, you plug it in. May or may not work. Reason being is because, you can take a look at the screen here. You'll see on the duplex connectivity side, you'll see that you need actually two different jumpers in order to connect this system into play. But here's what I was referring to earlier. Take a look at the right-hand side. Say we're using a method A system, and all of a sudden this is a duplex system. And, we did our best managing the system all the way, for all these years. And now we have some MPO-based transceivers that are coming in, and I want to run this over my infrastructure. Well, take a look back. So those on the left-hand side, those are what's inside are those cassette modules. That's how the fiber is wired inside of there. So now I have to pull those cassette modules out. I want to utilize that trunking on the backside. But take a look at the positions of not only the MPO, but also the genders of the MPO. You'll see there that on the parallel side, all of a sudden it switches over to male. So even if you're running method A, okay, in order to go over parallel optics, first of all, you're going to be missing the gender, which you absolutely need to connect to MPO connectivity. And then if you're then need to put the gender on the jumper side, which goes you away from the standard, you won't be able to plug that into a transceiver because the pins are very standard inside of your transceiver. So you can see there how that becomes a pretty big challenge. Besides the fact is, again, you're ordering two style jumpers. A straight jumper on one side and a flip jumper on the other side. So you have path and gender to be concerned with there. Switching over to or talking about method B, again, a lot of companies and a lot of customers, data centers utilize method B. It's a good system. However, the most, I think, thing that stands out drastically with method B is that in a duplex scenario, meaning a trunk cable into cassette modules, you have to have an A side and a B side cassette. Now, me, sometimes, I'm scatterbrained. So if I was implementing this into my system, if I needed 30 cassettes, I need 15 of one kind of cassette and 15 of another kind of cassette. And I have to make sure that 15 are, implemented on one side and 15 are implemented on another side. I think I can do it, but sometimes some of the people that I've hired over the years might have a challenge with that.
It may not be plug and play like you were saying earlier.
Not so much. Okay. But, the good news with this is that at least I only need one style jumper. So at least that's good. Okay.
Yep.
But now let's take a look again on the right-hand side. Okay. Now we need parallel optics. Okay. Well, again, take a look at, two things that stand right out to you. Okay. First of all, all of a sudden my trunk now needs to become a male. Okay, well, there's very few options out there with installed base that you're able to switch these genders, okay, of these particular connectors. So long and the short of it is, now you have to buy, a jumper that has male on one side and female on the other. Again, it will work in the system there when we pull these cassette modules out. However, it will not work with a machine-to-machine plug-in, for example, on a spine and leaf type connection. A leaf switch to a core. You can't plug that in. You can't utilize the same jumper. Or you might have, Tony, the installer or guy working for you trying to jam this male plug into your $1,000 100 gig transceiver and damage some things. Okay,
Yep.
So inherently, again, all challenges. And I didn't even bring up what I think is, which really makes Method B a non-usable system, is that there's a vendor out there that has a patent on the intellectual properties of FiberPath for single mode version of this. Again, not to get too techy, but in the single mode version of the MPO interconnects, the MPOs actually have to be angled. Okay, that's required because of the ferrule type and things of that sort and the laser transmissions. But anyway, they're made with an 8-degree angle. That's standard. Right. If you take a look again at the scheme, you'll see the adapters there with MPO. Now again, the MPOs are not only not only have genders associated with them, but they're also keyed.
Yep.
So these adapters obviously have to have keys on both sides. So the Method B adapter that's spec'd in the system is a key up to key up. What do you think happens when you plug a key up to key up angled MPO connector together, JT?
You're going to have an air gap.
A big air gap.
That's not good.
Angles are going to hit each other.
Yep.
Right. So you basically have to go out and find a proprietary cable that builds something away from what's supposed to be standard, besides the gender worry about that we talked about.
Right.
In order to try to make this system work. Now, why do I bring this up in single mode? Okay, because again, short reach single mode is becoming a big factor in data centers. Okay. Right now, the average cost of short reach single mode for 100 gig is about on par with multi-mode transceivers. And we all know that single mode infrastructure is probably about 70% of that of multi-mode.
Yep.
And OM4, and when obviously OM5, it's the costs are high right now because it's a new technology. So yeah, it's probably more than 50% less expensive than OM5.
Okay.
So that's one thing to consider. All right. And then finally, method C. Okay. Again, a good method for has its advantages for some things and disadvantages for another. It's our opinion that method C in duplex connectivity is by far the best method. It uses one jumper, one trunk, one style cassette. Okay. It doesn't matter how many interconnects you have; you're at the right spot every single time. Great system for duplex connectivity. However, when you switch over to parallel optics, not so much.
Yep.
Not saying it can't be utilized. However, there's costs involved, okay, similar to that of method B for switching out product and things of this sort. What you have to do is, obviously, if you think about the path, if you take a look at what's happening going on here, this system utilizes a pairwise flip all the way through the system. So fiber 1 through the whole system goes to fiber 2. Parallel optics, we need fibers, the first 4, to go to the last 4. So in this, we would have to implement, for example, a cassette system on one side that basically straightens the trunk out, so to speak, or straightens the pairs out, and then actually flips it. Okay, so then you're talking back to 2 different style cassette modules on each side.
Yep.
Okay.
Yep.
So that's inherently what the challenges are for method C. So again, each of these systems, they have their own unique set of advantages. Okay, but nothing holistic as far as works in every type of scenario, cost effectively. All right, and that's what we're looking for. Okay, so that's what the challenge is. Also inventory management. Okay, a lot of people set out with good goals, just like when you first implement infrastructure, if not designed properly, everything looks good when you first plug it in if you do a good job. Okay,
right.
But how many data centers have you been through, JT?
Oh, a good handful, and I don't.
Are they all pristine?
Nope.
No. Okay. Unfortunately,
Nope.
It's more the norm than the standard, right?
Yep.
So this is the case. You might set out and say, I'm going to manage 2 different style inventory cassette modules, A sides and B sides, or core and edge, 2 style jumper cables. Okay, it simply doesn't work out that way. You're going to have a guy that you hire 3 years from now. He's going to come in. He's going to plug something in. It's not going to work. Things are going to go down. You're going to call, yell at vendors. Vendors are going to say, well, what are you doing? And it's a whole. It's just a tornado effect all the way through. Right? Mm-hmm. Again, not a plug-and-play system. It implements downtime, and nobody wants that. And we certainly don't want any kind of like ripping and replacing. Okay, again, if I'm spending big dollars and big investment to put in an infrastructure. I want it to last several years.
Yep.
Okay. So, introducing multipath. All right. Again, myself and my team have been working on this for a few years, and I think this is the way the interconnect should be in a data center. Okay. I'll go through some bullet points with you. All right. So again, it's designed with one style trunk for parallel optics and/or duplex connectivity. It's one. Okay. You're only ever going to buy one trunk. Okay. Again, it's designed to work with single mode and multi mode. Okay. Not having to worry about what we talked about, angles hitting each other and creating air gaps.
Right.
So it works with both. Reason being is because we utilize a key up to key down adapters, and we don't have to worry about those particular things. Uses one style jumper. Okay, so when you buy an LC jumper, you buy an LC jumper, you use it everywhere in the system. One type of jumper for parallel optics, an MPO to MPO jumper, whether it's plugging machine to machine or whether it's plugging in a structured cabling system between adapter panels. Okay, one type of cassette module. Okay. So, you order one cassette module, you put it anywhere in the place that you want it,
yep.
The system works, okay? And what that does is it gives you such an easy migration from parallel to single mode, because what you're doing is, for example, if we build a simple duplex system here, okay, we have an MPO trunk, two cassette modules on each side. I need to go parallel optics now. All I need to do is pull these cassette modules out. I slide an adapter panel in, okay, an MPO adapter panel feed through, plug the MPO back in, okay, and connect it with a standard MPO jumper, and I'm up and running. I need to switch back over to duplex connectivity. I just unplug the MPO adapter or unplug the MPO jumpers, plug the cassette modules back in. Same ones, no conversion modules, no A-side, B-side stuff, no additional cost. It's simply flat out, as far as putting this in the data center, it's an absolute must, all right? We take care of the genders for you. You don't have to worry about where I need to be male, where I need to be female. It's truly a plug-and-play system with just 4 standard parts.
That's great. That's great. So no conversion modules needed because what I'm hearing is you're going to have some MPO-based transceivers.
Correct.
And then you might very well go back to a parallel or LC. I'll just keep it simple. LC-based.
Right.
Back, forth. You don't know. Proprietary, non-proprietary transceivers. Right. You're not buying because that's what we've seen in the market. Sure, any method could do it, but you're buying a very expensive conversion module to do that, and then you're taking out an expensive conversion module, probably losing it, and then 2 years later you probably need it again.
Right.
So you don't have to.
By that time, it's all dirty.
That's exactly right. Yeah. Probably got used as a hockey puck or something.
Exactly.
So you don't need that with the multipath.
You do not need that with the multipath.
That's great. Okay.
It's by far, it really is, we think that the forward path in the data center. Again, reason being for those exact reasons that you just stated, okay? It works regardless of the technology. See, us as cable vendors, again, for lack of a better term, we shouldn't care how the customer is getting to their higher speeds as far as the method that they choose to use, okay? It's our job to lay the highway and make sure the cars are able to run at their optimum speeds down the highway.
Yep.
Okay? It doesn't matter to us whether you're doing duplex or parallel. We just need to make sure that it works. And if they choose, one particular vehicle at the start of their system and they switch over midway through, or if they have a mix of both, our infrastructure needs to support all that way cost effectively. Okay?
That's very cool.
Absolutely. So again, I just threw up on the screen in case you're interested in looking just a couple of, kind of just core, diagrams here, just showing you how easy this system is. I mean, here's a standard, I'm plugging into a core. I'm going through a structured cabling system, that MPO adapter there. I'm going into a trunk, going out to a cassette module. So I go from, parallel on one side to duplex on the other side.
Yep.
Okay? Easy. All right? All of a sudden, say, if you remember the last drawing on the left-hand side, okay, same scenario on the right-hand side, but now I want to take out that cassette module, and I want to hit various different LCs on my switch there. Boom. Pull out that cassette module, slide in that adapter panel, and I plug in that harness style cable. Easy to do, okay? Genders are already taken care of. We don't have to worry about that, all right? There's a scenario again. There's strictly a duplex link from end to end. Again, one LC jumper, the same on each side, one cassette module, the same on each side, one style trunk, okay? Works on both sides, all right? That same link, if you remember the slide again previously, I know this is hard to follow when you're flipping through slides, it's sometimes hard to follow the diagrams, but this is a scenario where previously, okay, this is a duplex system, and here's what we're really referring to, right? So now I have a duplex system, just say I'm using BiDi, right? I'm transmitting 40 gig. Okay, well, I need 100 gig now. I got some new switches in, boom. All right, now on each side, my jumpers become MPO based, okay?
Yep.
I pulled those cassette modules out. I put those MPO panels in. Therefore, I'm utilizing our same enclosures that we already have in our racks. Put feed-through adapters in, and I'm plugging right in, okay? No cost, with the exception of, obviously, the adapters.
Yep.
But no, I guess, pricey equipment. No conversion modules or anything, okay? The system works. The gender is already taken care of on the MTP trunk, regardless of what you're using. The genders are already taken care of on the MTP jumpers. They work plugging it in to the machines, as you see, and they work plugging it into the structured cabling system with the same type of jumper. You can take this jumper, for example, out of the structured cabling system here, and you can just go machine to machine and connect if you had a scenario like that. Again, simple.
Yeah.
Simple. Again, truly what I think the actual term plug and play means. Okay, 4 products, the same, regardless of what you're doing. Never have to worry about fiber path. Never have to worry about gender. Okay, so no inventory management. Makes everybody a fiber expert. You won't be sitting hours on the phone tracing fibers trying to find out where something went wrong. And believe me, you and I both been on those conversations.
Yep. Okay? Yep.
It's simply a phenomenal system. Obviously we're not on video here, but if you saw my gray in my beard, that showed my age on how many years I spent in the data center, with some issues and things of this sort. But this truly eliminates probably about 99% of your headaches.
Hmm. Well, I'll tell you, as this was developed, some of the concepts are very simple, but, you scratch the surface. You just think, hey, I just want to plug it in. And I think that's a lot of end users' mentality. They have so many things to worry about past layer one, and even the political, environment that they're dealing with now. And, hurry up, hurry up, hurry up. It's very busy. So having a true plug-and-play solution, I go to that term. I mean, that's been used so much. It's cliche at this point.
But it's funny how you bring that up by saying, you just want to plug it in.
You just want to plug it in.
That's how simple it is, right?
Yep.
You just want to plug it in and want it to work.
And everybody has been saying that for 2 decades now, but it's never really been that way. It's like, well, it's plug and play, but plug and play, but. Right. And I like this solution, having our team worked on this, but you just try and make it as simple for the user as possible.
Right.
There's inherent issues with anything. You just want to make it as simple as possible. Take all the guesswork out of it. That combats with, you touched on the point today of, some proprietary type of things, because ultimately manufacturers want you to buy their products.
Right.
So that's always been the frustration we've seen from the users. Yeah, it's great. It looks great. It's marketed very well. But man, once you get into it, once you invest in that initial solution and it looks great, now down the road, now I got to pay out more. I got to pay out. I got to buy new stuff.
And then again, not to mention downtime,
Right.
Nobody wants that.
Nobody. Rick, so I have a question. Earlier you pointed out, people aren't just building something new. If you build something new every time you added things to your infrastructure, probably be pretty easy, but that's cost. And all right, this is just not realistic for business. So you have an existing infrastructure. You might have method A, you might have method B, you might have method C, and you want to start utilizing multi-path system. How are you going to manage that? Because now you're adding an additional system. I mean, that's got to be inherent problems, but is there a way to mitigate those challenges?
Yeah. So for example, I mean, one of the benefits Cable Express has is, we have architects that we spend 80% of our time in data centers, and the other 20% on standards boards and training people. So there's not a if you continue with those particular methods that you chose, you're going to have the challenges anyway.
Yep.
Okay. So what we would do is we would mitigate that. Meaning is we come in, evaluate what you had, and show you the easiest migration path to utilize your existing infrastructure. Get it set. Okay. Make sure that now we know what the connectivity is. Bring it to where it needs to be as far as duplex connectivity goes.
Yep.
Okay. Or parallel connectivity goes, and then implement the multipath system in addition to that. Once we implement that, then moving forward, it can be all multipath. Like I said, this multipath is not proprietary technology. Okay, so we have the capability to manufacture certain products to bring that system over to a multipath style interconnect.
Okay.
So for lack of a better term, there might be, because I know we talked about a lot about conversion modules and things of this sort. There might have to be some conversion with the other methods over to what the multipath method should be, but those costs will be minimal.
Okay.
Once we get over to that system, then moving forward, you're good to go.
Okay. No way to avoid that, obviously, because you have that older system with its inherent problems. Nothing you can do.
But here's the thing, too. It's a lot of people don't realize this. Maybe I shouldn't broadcast this to the industry, but I mean, these things that we do, the architects, my team, they're no charge. So utilize us. This is what our job is. We'll come in and evaluate what you have going on, and we can make a recommendation moving forward. It's as simple as that. Whether you choose to use us or not, that's where some of our value is. So bounce ideas off of us. Give us a call. Like I said, my architects, my team are scattered throughout the country. We can certainly arrange any kind of meetings that you might see fit or have some time for infrastructure evaluation.
I think I will tell you, go back to, my original thoughts of just seeing at the Gartner 2017 data conference, things are so busy. The value proposition you just spoke of that we offer is absolutely sound. People just don't have the time. They need resources. We're an excellent partner for that and for the use of our architects right there. You guys know what you're doing. You know what you're talking about. We have multiple ways to help out customers, but it is a resource, and it's essentially a free resource for customers to use. Something that is very costly, that often just gets minimized or not even recognized, that causes major problems. You're the one who sees it all the time. You're gray beards from all those problems that happen in data center cabling. So